Okay, guys, here we go with what we call the side splitter theorem, the side splitter theorem. Now let's just construct this as it's indicated, okay? So it says I'm going to take a segment parallel to one side that's going to pass through the other two sides, and it's going to divide those two sides proportionally. So here's what I'm going to do, okay? I'm just going to select one of my sides. I'm going to construct a point on that segment, okay? And then I'm going to go, that can be anywhere along that segment, so that can move around. Now what I want to do is I want to construct a parallel, okay? So I'm going to construct a parallel line through that, all right? So this is the conditions that I have, okay? So I have this, I have the segment is parallel to one of the sides, so this segment that I just constructed is parallel to side AC, and basically it's going to end up, okay, it's going to end up splitting these sides proportionally. So here's what we're going to see, okay? So let's mark where these two intersect, okay? So we'll construct the intersection there. We're going to label these D and E, all right? So what happens here is that GE is the segment that's parallel to AC, okay? Good enough? At all times. Anywhere I move it, it's parallel, okay? In fact, if I want, I just make a segment out of that and do away with the line, okay? So we'll do it that way, so we can be more in keeping with what the theorem says, so the side splitter, okay? Now, what it says here is, okay, the segment AB and BC are going to be split proportionally. That is going to say, if I take the distance from B to D, measure that distance, okay, all right, and I'm just going to keep these all over here, and I'm going to take the distance from D to A, I'm going to measure that, okay, and then I'm going to take their ratio, all right, then I'm going to take their ratio, so I'm going to number, calculate, and I'm going to take BD, the top, over the bottom, okay, and that's going to give me a ratio. And what I'm going to do is I'm going to look at the top to bottom ratio over here as well on the side BE. So BE, I'm going to measure BE, I'm going to measure that, okay, put that distance over here, and I'm going to measure my length EC, okay, I'm going to measure that. Okay, and now I'm going to take the ratio again between these two. Okay, so number, calculate, ratio of BE to, okay, EC. And lo and behold, I get the same ratio. All right, so what it's saying to you is basically this, okay? And this will happen however I move this along, however I change the triangle, that ratio is going to be consistent. You can see that right there all the way through, okay? So basically it says this, okay? Take a triangle, okay? Draw a side in here which is parallel to one of the sides, okay? So I draw a segment parallel to AC. And what I do is I get a top to bottom ratio. The top portion of the one side of the triangle, BD to DA, is the same as BE to EC. That's the proportionality I'm getting in this case, okay? So anytime we have this side splitter, that's what it says, side splitter, okay? Take a segment passing through one side of the triangle parallel to another side, okay? And it will divide these two remaining sides proportionally such that the top to bottom ratio is always the same. Top to bottom ratio is always the same. No matter how I distort this triangle, that ratio is going to remain the same, top to bottom ratio. And there you have it. That's the side splitter theorem.